In an ionic compound, a positive metal comes together with a negative nonmetal. There's a simple way of figuring out what the formula is for that compound, and it's based on the ratios. Here I take a look at it. Here's a quick video on how to write the formulas for ionic compounds. In ionic compounds, we need to balance the positive charge of the metal with the negative charge of the nonmetal. We use what's called subscripts to show the ratio between the two elements. But we just have to figure out what those subscripts are. So to do it, we have to first identify each ion and its charge. That's step one. You got to look at each element and you find out the charge of the ions that you're trying to put together. Then you have to find the number of charges needed to balance the positive with the negative. And finally, you got to figure out the ratio and then use subscripts to write the formulas, but you can't use one. So I'm going to go through this with sodium chloride. We take a look at the sodium and chlorine ion. We see that we've got a +1 and we've got a 1- here. And that's because we've got a metal, the sodium, and a nonmetal, the chlorine. Sodium becomes positive when it loses that 1 electron, whereas chlorine becomes negative when it gains 1 electron. And both of these have a full shell. So we look at those ions, and then we have to figure out the number of charges needed to balance. Well, when you look at a simple plus and a simple minus, it's already balanced. You don't need to do anything. You've got +1 here, you've got -1 here. So when it's balanced, the only thing that you need to do is just write out the symbols for the two. So NaCl, no subscripts, because if it's a 1, we don't put any subscripts in. Now let's look at one that's a little bit more difficult. We've got calcium fluoride here. Now with calcium fluoride, we've got a 2+. That means it loses 2 electrons to become an ion, whereas fluorine, it is a halogen, so it just gains that 1 electron and then it has a full outer shell. So when we're putting these two together, we've got this 2+ here that we have to deal with. We want to balance it. So if this is 2+, we need a 2-. How are we going to get a 2- when we only have a single minus here? Is that we need another fluorine ion. And now that we have 2 minuses, that makes 2-. So when we're writing our symbol, we would say CaF2, just showing that we need a 2-to-1 ratio, 2 fluorine ions for 1 calcium ion. Now the final one here is just slightly a little bit more difficult, but not really. When we look at aluminum, it's a 3+, oxygen is a 2-. So you think, okay, well if I have 2 oxygens, then I'm going to have a 4-. It still doesn't jive with the 3+. If I double the aluminum, I'm going to have a 6+. They still don't jive. So what do? Well, we find the lowest common multiple. So it's very simple math. With aluminum, we're counting by 3s. 3, 6, 9. With oxygen, we're counting by 2s. 2, 4, 6, 8. And we find that lowest common multiple, which is a 6. And that means that both of these, the aluminum and the oxygen, need to add up to 6. 6+ for the aluminum and 6- for the oxygen. So in order to get 6+, we need 2 aluminum ions. And to get 6-, we need 3 oxygen ions. And then we just write the ratio. Al2O3. And that's it. It's that easy. Thanks for watching.